EcosimPro and PROOSIS are software tools for simulating and modeling systems. In this example, we're going to show you how to set different initial conditions in the simulation. We'll use a model that includes the dynamics of projectiles shot from a cannon from the American Revolutionary War. Friction in the vertical and horizontal component of the movement is a force proportional to the product of the modulus of the projectile's velocity times its component on each axis of the movement. First, we load the Book Examples toolkit into the workspace. Next, we open the file that has the equations of movement along the x-axis and y-axis. In this case, they're the ones shown for the movement on the x-axis and on the y-axis. The experiment introduces the new variables for the projectile's initial exit velocity and the angle of the cannon. The initial conditions are also included in the variables of initial position state x equals 0, y equals 0, and initial velocities as a function of the angle of the cannon and the projectile's exit velocity. The experiment is run in the monitor up to the 22nd time indicated in the experiment, entering the variables of the simulated model x and the position y in a plot where we can see the results. Finally, we see the results of the curve of the parabolic shot. Now let's try different shooting angles and superimpose them on a single chart. We'll do it by generating a new experiment, EXP2, where we enter different sets of integrations at different exit angles of the projectile. To start each integration, we execute the reset command to reinitialize the status variables executed by the init section, containing the equations that depend on the exit angle. A more concise way to do this is to use a for loop, as can be seen in the generated experiment EXP3. The value of the angle variable repeats from 10 to 60, going up by 10 in each loop. As the graphic shows, when the simulation is run, the projectile does not stop when it hits the ground. To improve this, the model can be changed by adding a status event to the component. The discrete section includes parts of the model that are only executed at particular moments of the simulation. A when sentence is added to assess the condition, and if it's met, it runs. In this case, it executes the stop sentence, and the experiment stops. After compiling and generating the default partition, to close the mathematical model with its equations, we generate the associated experiment. We can see the execution now stops right when the projectile hits the ground. However, when several shots are interspersed, the simulation stops from the first impact, since it executes the stop sentence. Since the goal is to go on and integrate the next shot when the first one impacts, the component has to be changed so that t_stop equals time to make the stop time equal to the time of integration. After compiling, generating the partition, and executing the experiment, we can see that maximum reach occurs at 40 degrees. In conclusion, this video has shown how to run different simulations to calculate the parabolic shot by entering discrete events in the component and different modeling options to solve this example.